Welcome to this episode. We will do a lot today. Last time we just rigged our character and make a simple idle animation, and this time we really will animate the character, and we can after that walk around and jump, and you will see a fully animated guy. Okay, let's have a look at the comment section very quickly. Looks very nice, thank you. Cool project, but from a tutorial point of view this is way too fast. Yes, it is. I will make it slower. Awesome video, thank you. Tell me it's going to snow. Finally a tutorial that shows how to create Lego games in Unity. Instead of modeling figures by hand, you could use meta bricks. So, and I said valid statement. Yes, you could use some libraries for figures, some libraries for bricks. You could also download a complete Lego game online and play it. But that's not the point here. So this is where we stopped the last time. This is our Lego figure. No, not quite right. We stopped a little bit different because now we have a face. So if you want to know how to do it, I created another shader called Lego Shader Text for texture. And it's basically the same shader. This is a shader for our Lego brick, and I added this one. So what did I do? I added a property called Texture 2D. I added a UV node. Put them together in a sample texture 2D node, and then linear interpolate between these and that. As you can see, here are stripes and so on. So why is it the case? If you open the PNG, it looks different because this is completely alpha. So you can use this alpha channel to really have the value of interpolation between those two. So the yellow is taken from or the color is taken from here if there is a high alpha channel. If the alpha channel is 0, it's taken from here. So this is the result. We put this in the albedo and we have a nice face. Okay, last time we had an animation, an idle animation, and there were no one animations yet. So this is what we do right now. Okay, let's play the scene because we are using inverse kinematics and it's only running in play mode. Okay, let's select the figure, go to the animation window, and here we are idling. It doesn't show us the one animation. I don't know how it really works, so I will just create a new one. For me it's the easier thing to do. Okay, let's start with meta rig. So we just hit record, and as you can see the idle animation stops because now we are in the one animation and the figure basically does nothing. Okay, let me just draw how a one animation works. So we have 4 poses. The first one is here. This is the head I'm just drawing right now. The one is a little bit underneath, the next one is on the line again, and the next is on top of the line. So, and you may notice this one is what will follow. So this one would be here. So we have an up and a down. Okay, what about the legs? So this leg will be here. And the important one, so we would skip the other one, but the other one would be here. And on the contact pose, contact the ground. So next time the leg is here. And the other leg is here, flat on the ground. And then here the leg is here. This is a dotted one, so the dotted one is here, and the other one is here. And then we really got it and say, okay, this one is here, and the dotted one is around here. So there we go. And then we just do the 4 steps again, but this time we change the legs left and right. Let's first start by the meta rig, and just choose the position we want to have. Go a little bit down to have our first pose. Then we go, maybe I will zoom in. Can I zoom here? Can I zoom? Should be possible to zoom somehow. There we go. Just control and scroll. Okay. This time we're going deep here, going up again, and then the last pose, if you remember it, it's very, very high. So, and then we're going down again. And then we're going really down. Back here. And I guess really high again. Yeah, looks quite right. Looks okay. As soon as I select them, I can scale them, for example, to a minute. Let's play it. Ah, looks better. What we should do is copy the last one. Just take this one and place it here. Okay, the first and the last one should be the same. Okay, this is what it looks like. It goes up and down. Perfect for our purposes. Okay, back in edit mode, I would like to change the knees. They should be here. Left knee, right knee, and elbows, maybe here, left and right elbow. Makes more sense because we will animate it right now. Back in play mode, we grab our left foot as the first one. The easiest way is to use this setting, because then you can scale, rotate, and move the thing with one control. And we will start like this. So this is the first pose. Pretty easy, yeah. And we go to the next one. There we go. And just put it here. And the next one, just put it here. And again, the next one is just our highest pose. And now this is our first rockstar kill. Yeah, let's continue. Now it should do exactly what the other leg is doing. So this is a contact pose. You should really make ground contact. There we go. Maybe the rotation is sometimes not right, but we will fix it later. So go. Now it's here. The next thing is clear. Should be here. And then we're going here. And just rotate it. And yeah. That's it, I guess. I will skip the last one. I will copy it at the end. So let's take another foot. There we go. So this foot has the contact pose as the first pose. Should make ground contact. There is the ground contact. Everything is fine so far. Just rotate it. Set it here. Perfect. And next pose. Go here. Next pose. And set it here. Here. So this is the highest pose. It should just look beautiful. So there we go, 90 degrees, and yeah, around here, there we go, it looks perfect. And then up here, do I really have to comment this? I mean, it's clear where we're going. We do the same thing again. So I really try to have one line here and then around and a line back. So this is what I try to achieve. And I say, for me, that's it. You can spend way more time doing this. Yeah, let's go and animate the hand. So the arms are the complete opposite. So let's start with the left arm. The left foot is behind the body. So the left arm will be in front of the body. Maybe, yeah, this is fine. And let's go to the next one. It moves really fast. Now I can't see it. Is there anything like a wireframe mode? Yes. Okay. Let's do this in wireframe since we do not see anything. Just move it slightly. And here we go. We just put it here. Okay, and now it has to slowly go back. Okay, let's recheck. There it is. There it is. A little bit back. And then a little bit back. And then it should be here, it should be the extreme position. And then we go slowly back to our normal position. Here, okay, let's fix the elbow. Just real quick. Yeah. You should go down. You should go here. And then you should go back. And then you should go up. So if we increase the speed, it looks okay. If we go out of the isometric view, it looks even better. And there is even one flaw because we have one frame that is 2 times in there, and this is the first frame. We do need this frame, but later in the game I don't think we will just skip this frame, and then it doesn't look that creepy anymore. And yeah, that's it, the walk cycle is done. Congratulations you all. So there's one of my tutorials out there where I show how a player controller could work for first person, third person, and yeah, some kind of 1.5 person mode. And the scripts are already done. So what I would like to do is just copy the scripts. I will give you the link for this video down in the description. And let's see that we can make it work. This is a player script. You can also find the player and the controller script in the GitHub repository. The link is down below. You can find the complete project. So these scripts will be committed there. Have a look at the commits. There's one commit for each episode. So just go to GitHub, click on commits, and as soon as you're there are, yeah, not for every episode, for every important episode there is one commit. For example, here you see it for the episode number 3. So, and then you will see what has changed from this episode to the previous episode, but you can just say browse files and you get the version or how the project looked like after the 3rd episode. There is some input in here, jump 1z, x, look x and z, and this can be set by any other script. The player script will leave like that. We have a speed value, we have a jump force value, we have a rigid body, a look rotation. So on a wake we get the rigid body, and then we create 2 vectors, one vector, a look vector, and the velocity will set to the velocity of the rigid or to the input 1 vector, and the look rotation will set to the input look vector. And then the rotation is based on the look rotation, and if we jump, the script checks if we are grounded, and if we are grounded, we will jump. So if we go to the controller script, it's red overall, and the reason for that is it uses mobile input. If you would like to see this as a mobile game, please write it in the comments and I will create this field back in, but now it doesn't make any sense. So as an input we get our player, we have a rotation speed. We don't need that. A camera control, there we go, and on start we just need the player. The other things are not that important. Let's get back the rotation speed again. Okay, input. It's the input rotation x plus touch field distance x. We could just say input mouse position. So there's no delta x. Let's create a vector 3, last mouse position. And so the last mouse position is the input dot mouse position on start, and of course after we finish the update we will update the mouse position, and to have the delta we say the mouse delta is input mouse position minus the last mouse position. So, and there we go, mouse delta, this is what we wanted, x. Rotation y, the same goes here, mouse delta y. Okay, Yeah, it's clamped, so we cannot go further than everything else. You can have a look at the video. I explained it there with many drawings and so on. I want to continue this tutorial and won't go too much into detail, but basically we get the input rotation x and y. So the character forward is just the rotation amount the up vector by the input rotation x, and the left is the same, plus 90 degrees. And we will need those two because we want to determine the one direction, and this is the input get vertical plus, oh, so it seems that I can just delete this joystick, and then I should already be able to, yeah, so simple. Character forward times vertical, character left times horizontal, and then I get my one direction. And my look direction is just input rotation y rotated around the character left vector times the character forward vector. And then I just forward this and input, oh, it should be input get key. Okay. Character pivot is just the camera pivot rotated around the character rotation. And there we go, last mouse post. So this is how we just created the script. Okay, that was fast, but basically, if you've done this, you can add the player script, you can add the controller script, and of course you need a rigid body. And of course you need a capsule collider. There we go. Everything on the figure. And there we go. This is our capsule collider. Doesn't fit to this huge figure. So make it smaller on this side. Oh, wait. Figure. Go to capsule collider. Click it again. This is a very crucial part. Oh, no. It's wrong again. There we go. Here we are. Constraint freeze rotation. It should only rotate around the y-axis, otherwise the character will fall. And that's it. Yeah, 1 kilogram. Why not? Drag 0. Should be a little bit more drag. Like 0.01. Yeah, camera pivot is 0, 0, 0. This is based on the character's origin. So it's here. Maybe it should be around the head. And the head is 0, 0.8 and so on. So let's make the pivot point the head. Makes sense. And the camera distance should be 10. 10? I mean, the character itself is 1 unit, then maybe 5 is enough. Just let us add a plane. And yes, let's block out our level. A cube would be nice. Stretchy here, stretchy there. No? Yeah, there we go. The mouse is not fixed, so let's fix that. No, not input. It's C. So cursor lock state locked and visible false. Okay, but then this delta does not move. So this is not the logic we want to use. So we will just say input dot get axis mouse x and mouse y. This should fix our issues. Better! Oh, the speed is so slow. Let's fix this. 10 times the speed. Woo, it's working. So nice. We can move and we can run. Okay, so I changed it so that the lock state is here on start, and if I press S or maybe Q, then I get out of it to be able to edit. Okay, I want to scroll. So I would just say camera distance plus equals input, is there a scroll delta Y? Yes, perfect. I want to clamp this. So the new value is camera distance plus mouse delta Y, and the minimum value should be 0 and the maximum value about 10. Otherwise, every other value doesn't make that sense. Now we have a really cool feature. We can just scroll in and scroll out. And if we scroll in enough, we have a first person mode. Yes, cool. And we can scroll out again, and then we have a third person mode. This is what I wanted. This is what I like. So, and really smooth. So if you're complaining, what a first person game, just scroll in and there you go. What's that? What's wrong with his feet? It looks so... This shouldn't look like this. Wait. So everything is working in my Fast AK asset store asset. So everything is good, right? Let's take a tentacle. Rotate it. No, it's not right. There is a bug in the code and it's in the asset store. Fast AK 5-star. 5 stars. Oh my god, let's fix this code. This must be gone, this one, and this is wrong, and here we have to add more things. And so I will update it. So here we are, back on track. This time everything works as it should. It just took me 2 hours to find this bug and fix it. But make sure to have the version Fast AK 1.1, which is currently in review. Otherwise, you can go to GitHub and just get the scripts from there. Since we got that in place, we only need one other animation, and the animation is animation, create new clip, one sidewards. So, and there we go. We just do everything we already did, just to make the character one sidewards, and we basically use the same pose. This means it's basically the same pose. We will turn him by 45 degrees in this angle, and then we just have a look at our right foot, left foot. Let's start with the left foot, where it is. Y, minus 90 degrees. And yeah, that's basically it. And then we animate as we would usually should. So now I'm done. What do we have? Idle. We have one. I made two sideboards running. One is one leftwards and the other one is one rightwards. And yeah, that's basically it. We can edit our things like looping every animation. Yes, every animation is looping, and we have a cycle offset of 1 here to make the animation smoother. Okay, figure. Now everything is in here. We will change it by add something. Create a blend tree. And we directly go as a state machine default state into the blend tree. We will delete them and go into the blend tree because we want to blend between them. Okay, like a float left or side, and this is speed. Yeah, I think these are good names. Okay, then we need a 2D simple directional parameter speed. Blend, no, side. Add new motion field. And hopefully we can now insert. Yes. No, I don't want to add a blend tree. Let's add motion fields. A motion field for 1. A motion field for 1. No, it wasn't a mistake. And now one leftwards, one. The speed is -1, so it's basically playing backwards. Okay, now we have to position them. Let's see. Just imagine this is a character and these are the animations that should be played. Yeah, these are just test values. Okay, let's grab one. Idle. Idle is simple. Idle is in the middle. Position 0, 0. Next up, what do we have? One leftwards goes left. One goes here. One rightwards goes right, and one. This is speed. This is side. This is not correct. Clean the positions out. 0, 0, 0, 1, 0, -1, -1, 0, 1, 0. Now, this looks clean. It doesn't look that good, and the reason for that is we just animate these handles and the meta rig, so that's the reason why you see him walking up and down. But basically, it looks fine. Oh, I was in play mode. But these are files, and files are saved even though you are in play mode. Okay, let's set these values in a new script, and we can call it player animation. Okay, at first we grab the animator and the widget body. And the animator has a set float, and there we can, I think, enter a name and a value. ID and value, name and value. So speed is widget body velocity. So here's a problem. For example, this is our character, he's looking forward, and the velocity is going here, and this is the side of the character. Imagine this is a value 1, this is 0, and this is 1. So then this value here, or this axis, is a speed. And we do not set it to 1, we will set it to maybe 0.8, and here we want to set it by 0.9. So therefore we just project it on these axes. So what we will do is say vector 3 project, so vector on normal, so the velocity and the normal is widget body forward. Is there something like transform forward? There we go. And then the magnitude. We do the same with the side, and we take transform right and the magnitude. It already looks nearly perfect, so the problem is that he only walks on one side. So the reason for that is if you have a normal and then you have the thing you want to project, this value doesn't matter if the normal is pointing in this or that direction, so you will always return or get a positive value out of project. But yeah, if you want to know if these are pointing in the same direction, like these two, or in the other direction, you use a dot product. It's basically that simple. So, and the dot product just returns 1 or -1 or a positive or negative value. And if you take the sign, it either is, it's rounded to 1 or -1. So the dot product of the velocity and the transform forward and the transform right gives us the solution. So that's it for this episode. Yeah, our Lego man is walking and animated pretty well, pretty okay. We will improve the complete game style in the next video. Subscribe to my channel to get more straight to the point tutorials.